So I would like to discuss analytic continuation. Okay. Uh, suppose suppose that your one function f1 is analytic in a domain d1, say. Okay. So f1 is analytic. F1 is analytic in d1, and there is an analytic function d2 in d2. F2 is analytic in D2, and in this region, that means the intersection, and what F2Z is equal to F1Z for all Z in D1 intersection D2. So in the common points of the domain D1 and D2, your F2Z, values of F2Z are equal to values of F1Z. Okay, then this F2 is called analytic continuation of F1 to the domain D2. Okay, so your F1 is analytic in a domain D1. There is an analytic function F2 in the domain D2 whose values at these points, at the common points, that means intersection with D1, is equal to F1Z for all Z, right? Then F2 is called the analytic continuation of F1. F2 is called analytic continuation of F1 to the domain D2. Remember that there can be only one analytic continuation to the domain D2. Why? Because suppose there is another analytic function in D3, in D2, F3, say. So F3 is another, say, analytic continuation. F3 is analytic continuation of F1 to D2. Then what does it mean? This means that your F3Z will be F1Z for all Z in D1 intersection D2. But you see that F2Z is also F1Z for all Z in D1 intersection D2. So F2Z, F3Z are two analytic functions in the same domain D2, and they agree in a subdomain D1 intersection D2. And we know that an analytic function is uniquely determined by its values in a subdomain or a line segment lying in the domain. Okay, so because D1 intersection D2 is a subdomain of D2, so you see that your F2 and F3 are same functions. So F2 and F2 are same actually in the whole domain. F2 and F3Z, these are all same for all Z in D2 because they agree in the subdomain D1 intersection D2. So therefore there can be only one analytic continuation to a domain, to a certain domain D2. Okay, but note that if there is an analytic condition F2 to the domain D2, right, of F1, then there is another analytic continuation of F2. Okay, F2, that means there is another analytic continuation F2 which also intersects with D1. So this is what D1 intersection D3. And because F3 is an analytic continuation of F2, okay, so these two are same, F2Z and F3Z are same in these points, and they intersect with D1 here. Okay, but in this case your F1Z may not be equal to F3Z. Okay, so that means an analytic continuation of one analytic continuation, another analytic continuation of the original F1 may not be analytic continuation. Okay, so F3 may not be an analytic condition, may not be an analytic continuation. Okay, so that means composition may not be the analytic continuation. Okay, so now I can give an example. So you see that suppose I define F1z equal to summation of Zn n equal to 0 to infinity, and we know that this is what? Analytic in. So this is nothing but what? 1 over 1 minus z by Taylor's theorem, and this is valid for mod z less than 1. So this is analytic in where? In this domain. So you see that this is analytic in this domain. 0 is 1. Okay, so your f1 function is analytic in this domain. But I can define also f2 function. What is this? This is, I can just define 1 minus z, and this function is defined for all z which is not equal to 1. All z not equal to 1. Alright, and this is analytic. Analytic in where? This is analytic in the whole complex plane minus 1. Okay, so this is say d2. This is d2. And what is your d1? Your d1 is modulus of z less than 1. And what is d2? Your d2 is c minus 1. Okay, so therefore this f2, you see that, and in the full domain, in the common domain, what is the common domain? Here common domain is what? D1. Remember that D1 intersection D2 equal to D1. Okay, so in this common domain both the functions are same. It is 1 by 1 minus z, and here also it is 1 over 1 minus z. Okay, so in the common domain the functions are same. So therefore I can say that f2z, f2 is an analytic continuation. Analytic continuation of f1 to what? C minus 1. C minus 1. That means whole complex plane except the point 1. So our original domain was this. Okay, so remember that this is open and connected, and the D2 is what? The full domain D2 except the point 1. Alright, and in the region intersection, in this region both the functions are same. So therefore this function defined by 1 by 1 minus z, where z is not equal to 1, is an analytic continuation of the analytic function what? f1z equal to summation of z to the power n, given by the Taylor series, and that is 1 by 1 over z for mod z less than 1, because this is equal to this only when what? Modulus of z is less than 1. Alright, so therefore f2 is an analytic continuation of f1 to this larger domain. Okay. So thank you.